Alright, today we are going to find the sample standard deviation. So, in the last video we did a population standard deviation. We are going to start by reading the question. So, find the standard deviation of the grades of a sample of 6 randomly selected students from all of the math courses at a school. So the grades are as follows: 23.6%, 14.2%, 50.4%, 83.1%, 99.9%, and 100%. So before we start, I got a couple of notes for you. The population standard deviation formula is sigma equals the square root of the sum, that little e means the sum, of x minus the mu squared. So what is the mu? The mu is the mean over the capital letter N. So what is our capital letter N? Our capital letter N is our population size. So let's say you have a population of 1 million. N is going to be 1 million. So that is your population size. In the last video, I kept saying N is sample size, but it's actually population size. I'm just so used to saying sample size all the time that it's a habit now. And the sample standard deviation formula is a formula we are going to use today. So it is S. Notice that sigma changes to an S. The S represents a sample, and this sigma represents the population. So S equals the sum, the little e, the sum of x, your x values, minus the mean, x bar. X bar and mu are basically the same thing, they're the mean. And then you square your sum of what you get, and then you divide by n minus 1. This is lowercase n. Lowercase n is for your sample size. Now that is your sample size. So you're going to minus 1 from your sample size. So that is, and then square root it all. So that is your sample standard deviation formula, the one we are going to use today. So they're very similar to each other, but today we're going to use this formula. So the standard deviation cannot be negative. So whatever you compute, whatever you compute from this cannot be negative. If it's negative, then you need to fix something. So the standard deviation measures how much the values deviate away from the mean. So it pretty much measures how spread apart the data is. So let us go ahead and start this problem. Let's see if this one works. Hold on a second. Let's see if this pen works. All right, so let us start by writing our formula. This is going to be, so S, hold on a second. So S is equal to the square root of the sum, little e, the sum. I think this is called uppercase sigma, but correct me if I'm wrong. The sum of your x values minus x bar, which is the mean, the same as mu. Mu is that little thing that looks like an M. That is your mean. So is your x bar. X bar is for the sample and mu is for the population. Then you square all of that and divide by sample size, not population size, lowercase n, minus 1. It's going to look like that. So uppercase N is population size. Just to make that clear, population size, sample size. So that is our formula. Let's go back to the question. So this is a sample because we are only selecting 6 students from the population. The population is going to be the students from all of the math courses at a school. That is a population. All of the students from the math courses at a school. So our population is going to be all of the students from all of the math courses at a school. That's our general population, but we're only selecting 6 students at random. So that 6 is our sample. That is how we know we're going to use this formula as opposed to this formula. In my previous video, I did this formula. So let's go ahead and compute the standard deviation. So you're going to need to list your x values. So let's go ahead and write down the letter x, the line, because we're going to actually tabulate this data. We're going to make a column, well, several columns. So let us go ahead and write down our x values. So what are the x values? The x values are the grades of the students. So 23.6 all the way to 100%. So let's go ahead and do that right now. We're not gonna convert these to decimals. We're just gonna put them like that for this example. So let's go ahead and do that right now. The order does not matter, so let's go ahead and do that right now. So we have 3.6, 14.2. So we're going to go ahead and do that for all of the x values, and I'm going to come back and we'll see what we got. All right, and we're back, and we have this. This is going to be our first column, so we are going to draw a line. Sorry about that. A line. That's a horrible line. A line to separate from the rest of our columns. So we're going to go back to our equation and we're going to see what it wants from us. This equation tells us to get your x values and subtract by x bar the mean. X bar is of the sample and mu is of the population. So subtract x bar. How do we find x bar? First, let's go ahead and draw another column for x bar. Just like that, x with a little bar on the top. How do we find our x bar? X bar is our mean. So we are going to have to add all of these numbers together and divide by the number of values that we have here. So in this case, we're going to divide by 6. So we're going to add all of these together, divide by 6. So let's go ahead and take out our calculator and do that right now. So 23.6 plus 14.2. So just add all of them together and divide by 6, and we'll come back and see what we got. So this is what we should have gotten. 61.86, yeah, whatever. We are going to round to 1 decimal place. So this will turn into 61.9. For this example, we're going to round to 1 decimal place. So 61.9 is your mean, your x bar. So you're going to write it down right here. 61.9. 61.9. So what let's just go ahead and write it all the way down. So 61.9, 61.9 for all of the values, you don't have to write the arrow, but all the way down. Just know that we are going to subtract each individual value by 61.9 next, because that is what our formula wants us to do. So it wants us to take the your x value, and subtract by the mean, 61.9, each and every single one of them. So we're going to have to make another column for that. So again, we are going to have to draw our line. Sorry if you can't see, I'm filming this one-handed. So other column of x, your x values minus the mean, which is 61.9. So let's go ahead and do this right now. 23.6. 23.6. So you're going to have to subtract 23.6 from 61.9, 14.2 from 61.9, and so on. 23.6 minus 61.9. 61.9. That's going to give us negative, hold on a second. I don't think that's right. So 23.6 minus 61.9, that's going to give us negative 38.3. Sorry, I was checking my notes. So negative 38.3. I'm going to write that down on the third column. Negative 38.3. Negative 38.3. And for the next one, 14.2 minus 61.9. So 14.2 minus 61.9, that is going to give us negative 47.7. Negative 47.7. Just like that. So you just want to go ahead and do this all for these values, every single one of them, 50.4 all the way down to 100. You want to keep doing that for all those values. So we're going to return and we'll see what we got. So this is what we should have came up with. So now that we do this, now that we did that, we are going to go back to the formula and see what else it wants from. So it wants what we got here, in parentheses, it wants us to square it. So what does that mean? It wants us to take every single value and square it. So that is going to be our fourth column. So we're gonna draw our fourth column. So it's gonna be x minus x bar squared. All right. So it wants us to, let's say, for example, we're gonna have to take negative 38.3 and square it and put it right here. Same with negative 47.7 squared and put it right here. So let's go ahead and do that right now. So parentheses, negative 38, oh crap, negative 38.3 parentheses squared. That's going to give us 1466.89, but we are going to round to one decimal place, so that's going to be 1466.9. 1466.9. Just like that. Round to one decimal place. Let's do the other one. Negative 47.7. Parentheses. Negative 47.7. Close parentheses. Squared. That's going to give us 2275.29, but we're going to round again to one decimal place, so that's going to turn into 2275.3. Let's go ahead and write that down. 2275.3. Just like that. So now that you get the idea, we are going to do that for every single value. Just this column. Don't worry about this. Just this column right here, what we got, this product, what we got from this, we are going to square. So only this column. Only square this one, only square that one. So we're only going to square negative 11.5 and all of these values. Just how we did right here. So let's go ahead and do that. We'll return and we'll see what we got. So we should have gotten that. So 132.3, 449.4, 1,444, 1,451.6. That is what we should have gotten for this column. Let us go back to the equation. What does it want from us now? The sum, little e, little uppercase sigma, the sum of x minus x bar squared. So it wants a sum of all of these. So forget about these columns. We're just going to look at this column. What does it want? It wants us to just simply add all of these numbers together. So the sum of all of these numbers is going to be, well, first we're going to have to add all of these numbers and find out what it's going to be. So that is going to cover this whole upper section of the formula. So simply just add all of them. So 14 sorry about that. 1466.9 plus 2275.3 plus 132.3 plus 449.4 plus 1444 plus 1451.6 7,219.5. That's what we should have gotten for some. So 7,219.5. So 7,219.5. 7,219.5. That is going to be our sum. So what does the equation want us to do now? So we're going to have to, let's rewrite this in the equation form. I want to show you something before we square root the entire equation. So don't draw the square root just yet because I want to show you something. So S equals the sum. We already have the sum of x minus x bar squared. We already have the sum right here because we just computed that. 7,219.5. 7,219.5. Now, our sample size. Lowercase n is our sample size, uppercase n is our population size. So our sample size, we're going to go here. Our sample size, a sample of 6 randomly selected students. So our sample size is going to be 6 because it's in the problem. 6. But what do we have to do to 6? The equation wants us to take 6 and minus 1. So what is that going to give us? That is going to give us 5. So let us divide this now. So S equals, let's divide it. So 7,219.5 divided by 5, because n minus 1, 6 minus 1, sample size minus 1, equals to 1443.9. 1443.9. 1443.9, just like that. But this, if we add a little to the power of 2 sign over here, this is going to equal your variance. This is your sample variance. Let's see if I can write it down. Sample variance. I might have misspelled that, but sample variance. So, this question isn't probably this question is not asking you for the variance, but before you square this, you divide it, you're going to get your sample variance. Let us look at the formula for the sample variance. So it's going to be s squared equals the sum of x minus x bar, the mean, squared divided by n minus 1. That is a sample variance formula. Notice how this has a square. Notice how this does not. Notice how this has a square root. This does not. What does that mean? These are inverses of each other. So if you square root this, which is a variance, you would have gotten this by using this. If you square root this, you are going to get the standard deviation. But if you raise it to the power of 2, you get your standard deviation. You raise it to the power of 2, you are going to get your variance. Let us square this right now to find our sample standard deviation. So sample standard deviation is just S equals the square root of 1,443.9. And that is going to equal to, let's plug that into our calculator and find that out. So square root of 1443.9. Oops. 1443.9. Sorry about that. 37.9. 1, we're rounding to 1 decimal place. So 37.9. We can round this up to the next whole if you want to roughly equals to 38. But let's just go with this answer. Let's just go with that. So your standard deviation is 37.9. Your variance is 1443.9. So this is what I mean by inverses of each other. You can get your variance by squaring this. You can get your sample standard deviation by square rooting this because they're inverses of each other. So just remember when you write down your answer to if you're writing down the variance, make sure to write it down as s squared. When you're writing down the sample standard deviation, make sure to just write it down as s, just like that. All right. So that is how we find the sample standard deviation. And thank you for watching and have a good day.